Hello friends, welcome to Java threading tutorial. In this video, we will see how to lock the shared object using lock and unlock methods. Previously, we protected the shared resource using the synchronized code block and synchronized method. This time we will use the lock and unlock. Lock is an interface from java.util.concurrent.locks. It provides methods for locking and unlocking the shared resource. So it's an alternative for synchronized code blocks or synchronized method. The methods are lock for locking and unlock for unlocking. Only one thread can occur the lock. If there are multiple threads, let's state this is thread 1 and this is thread 2 and this is the shared resource, right? And let's state that this is the lock to occur the shared resource. And if thread 1 already occurred the lock, thread 2 cannot occur it. So T1 is using the shared resource and T2 is blocked here. Once T1 comes out of using it, then T2 will occur the lock, and other thread, if there is a T3, that will wait. Or even if T1 tries to come inside, it will wait because T2 occurred the lock. So it will occur the lock after using the resource. The thread will make a call to unlock and goes out. Only one thread can occur the lock, other thread will wait for lock to be released. So it will be released using the unlock method. In this example, we will create modulus 5 generator with a 10 thread and see the reentrant problem. Then we will avoid it using the lock and unlock for resource. So for example, all 10 thread is going to use modulus generator, and modulus generator, if there is a number n, it will increment the n 5 times like this. So just for experiment purpose. So that means for modulus 5 to work between multiple thread, all this increment, 5 increment, should go in one unit. That means if a thread entered, it should execute all 5. It should not break in between. So if it breaks in between, then modulus 5 will not get generated. And we will see that when we go to the example. So one can also use synchronized block or synchronized method as well as an alternative to lock and unlock. So here, if you see, we are using the lock class from java.util.concurrent.locks package. From the same package, we are using the ReentrantLock as well. So our class name here is ex08 mod 5, and here we have a counter, and this is the mod 5. So this specific variable mod 5 will have a modulus 5 number. That means the number will get incremented like 5, 10, 15, and it will go on like that. So we will not increment this number like n plus 5. Instead, we will do n plus plus 5 times just to see the usage of lock and unlock when the object is shared between multiple threads. Alright, here as a public member, we are having a lock instance, LCK, we are calling it. Public lock equal to new ReentrantLock. Alright, so using this LCK, we can perform locking of the resource, or we can protect the resource using this LCK. We will usually make a call to lock and unlock on this specific object. So that's our mod5 class. Now let's see using the lock. ex08 mod5 gen implements runnable. So since it's a runnable, we have a thread ID. That's by default we are giving it as 0, and obj mod 5 we are setting it as null. So this is instance of our shared resource which we created previously that contains a ReentrantLock containment, or ReentrantLock has a data member. Here we are generating the we are providing the constructor for this mod5 gen. Here we are giving the thread ID, and this is the shared resource. So in the previous slide we saw the mod5, right? Mod5 gen that contains a counter as a member, and it contains a mod5 number, then a lock. So it contains 3 members, and that is given to this runnable thread or a runnable class as an instance. So when we create multiple instances, the mod5 generator goes as a shared resource. Right? So we initialize the thread ID and our shared resource as an internal member, obj mod5, and the incoming member is initialized here in the run method. Boolean run t equal to true. So this is useful to run the thread, and if you see, the thread will run infinitely. When we set this run t to false inside the body, that time the thread will quit automatically. Right, log the shared object, and we commented it for experiment purpose. Note there are 10 threads initially. Only one thread can acquire the lock, and other will wait for the 10. So I just kept this comment, and you will see the meaning of this comment when we progress through this example. So initially we are not locking it, and we are running the resource, or we are running the thread. And inside the thread, since it's a shared resource obj mod 5, if you see, we are incrementing the counter to know we are generating the modulus 5 for the first time. And here if you see, successively we are incrementing the object 5 times to generate the mod 5. This may not be the good logic, but to experiment the lock and unlock, we are doing it like this. So when all these increment goes without context switching means these are all thread, right? If two statement is executed, and if it goes out and then other thread picks and increments the shared resource internal member, then you won't see mod 5 on this specific member, right? So that's the goal. Here we are incrementing it 5 times. Then after this 5 time increment, we are making call to thread.yield. Next, using the counter here, we just set some random number, and when it returns 0, this is a modulus division. Here there is no sleep, if you see, and we don't want to bombard the console window with the outline print message. That's why here we are randomly picking specific count. Therefore modulus is done for this many times. Then we are printing the mod 5 in the console window. When we are printing this for examination purpose, we want to see the number ends with 0 or 5. So if it ends with 0 or 5, then modulus 5 is going on perfectly, right? Or all these 5 increments are done in a thread safe way. So reset the counter 3 times and quit the thread. Here once again we are using this counter. This time we use 60,000 as the number, and if that's the case, we reset mod 5 to 0. So it will print the number 0, 5, 25 or something like 1, 2, 4, 5, 3, 7, 8, 0, and after that it will reset and go on 1, 4, 2, 0. We don't know which number it will print. So at certain stage we want to reset the number, and our goal is to see the number ends with 5 or 0 and modulus is calculated properly. So after this, once again we are incrementing the counter, and if t counter goes 3 times. So whenever we reset the modulus, we are incrementing the counter. That means here if t counter goes 0, t counter, if you see, it starts from 0, and when it goes to 3, it means 0, 1, 2, 3 times we are resetting it, and 4th time we are quitting the modulus counter, right? Run t equal to false. That means here our while loop will quit. While loop will quit means the thread will quit. Right? Run t becomes false, and here we are saying quitting thread ID. So if you see, all threads are, if there are 7 or 8 threads, all thread will print mod 5 periodically. So this is the key to examine the lock and unlock stuff. Here we are printing the modulus 5, right? And we want to see, this is printing the number that ends with 0 or 5, so that the increment of this mod 5 shared resource is happening in a thread safe way. So without lock, this will give problem. When we are going to demo, we will initially run like this. After that we will remove this lock and unlock. Here if you see, we are keeping a lock here, and we are reducing, or we are doing the unlock towards the end. The perfect place to do lock and unlock is wherever the modification goes. So the modification goes here, right? In this place we have to do lock and unlock. So the perfect way to do lock and unlock is during the access of the shared resource. Here if you see, this is the shared resource, and in shared resource we are actually performing the write operation, right? So before writing we have to make a lock, and after that we have to perform an unlock. But here we are keeping the unlock towards the end. Alright, now in the main program, if you see, we are creating our shared resource, shared mod 5. Then we are creating a cached thread pool, and here thread pool.execute, we are creating our new mod 5 gen. And to the constructor, we are passing the thread ID as well as the shared resource. So this is the shared resource, right? And if you see 1 to 10 the loop runs, that means there will be 10 threads here, mod 5 gen thread, and all 10 thread run in parallel and try to print the number, I mean the modulus number. Now we will create a class, and this is our mod 5. So as you already saw in the slide, here we have 3 members. So one is the counter, how many time the mod 5 is generated, that will be tracked by this counter. Here we will generate a modulus 5 number. Here we have the lock and method called ReentrantLock, I mean the constructor. So the lock is, if you see, that's the interface. Through this interface we will make a call to lock and unlock, but the actual object what we are creating is ReentrantLock, so useful for doing the synchronization. Now we will create new class. This is our mod 5 generator class that implements a runnable interface. So just provided the body, and in the body you can see we have thread ID and obj mod 5, which is an instance of ex08 mod 5, ex05 mod 5, ex08 mod 5. So these are all the members. All right, so we have this as an internal member, and that will be initialized by the constructor. The constructor also provides the thread ID, and we are storing it here. Then these are all the internal or auto variable for this run method. So these variables are specific to this thread. And first we will we will introduce this lock in the second run. This time we will run without lock, and you know, here we are making call to the counter increment as well as modulus 5 increment, and these logics are already explained in the PowerPoint slide. So this is just to print periodically the generated number, and this is to reset the modulus 5 to 0, and also to quit the thread. So if you see inside the run method, we don't have any sleep, so it may look like the system is, I mean the specific process is periodically hanging, but it may not be noticeable. But since the run method is running continuously and generating it without sleep, so it uses a high CPU for the thread's runtime. So once all threads quit, the CPU usage of CPU will be reduced. So these are all the main calculations that will do more memory write and thereby consuming the CPU. Alright, anyhow, here we are just experimenting it, and we are doing the experiment for a short period, so it will not harm your system. So if you are running on a low performing system, and try to reduce these two numbers so that you won't see the program running for a long time. Alright, now we will clear the console output, and okay, main is not yet ready. So here is our main program. Execute as service by this time you know. So we are spanning 11 mod 5 gen. Mod 5 gen is a runnable task, and we are handing over that to the thread pool or cached thread pool execute as service. We know that execute as service will span a thread and runs the run method in the runnable class in a separate thread. And we know that our run method makes use of the shared resource, right? Here you are creating the shared resource, right? Make use of the shared resource and its internal member ReentrantLock to lock and unlock the resource. The only mistake what we are doing here is we are locking the resource at the start of the thread and unlocking it towards the end. So the lock and unlock is not useful at all, because in the thread start we are locking it and finally we are unlocking it. So if that's the case, then we should have used a single threaded executor, right? But just to experiment purpose, we are using the lock and unlock towards the top and bottom. So in some cases, when you are accessing the shared resource, that time if you put lock and unlock, that will be useful. Here, since we are using this shared object at different places, we are not using the lock and unlock at a different location. In real world scenario, when you are writing something on the file, that's a shared resource, right? And during that time you can perform lock and unlock only when writing into the file, so that only one thread can put the result into the file, and when other thread comes, it will wait for the first thread to finish or first thread to release the lock by calling the unlock method, and then it will lock the file resource and write its own content. Alright, anyhow, even though we are doing lock and unlock towards the end, it still serves the purpose, and we will see how it avoids the problem of interlock. So the interleave happens here as well. This is the object, right? So interleave means if thread if thread context switches at this stage and the second thread picks up, and if it exceeds like this, then modulus 5 will not get generated properly, and that's what you are going to see now. Here we are not locking the resource, and we may not know when the thread context switch happens. there are 10 threads, right? And all are trying to generate the modulus 5 number and produce the output, and all are sharing the same shared resource and accessing the same mod 5 member. So since there is no delay, it generated such a big result. And if you see, mod 5 now is not correct, right? So here it is correct, ending with 5, and here it is ending with 9, ending with 7, 3, 6, right? And you can see there are multiple thread that is printing the modulus 5. And since all threads are sharing the same mod 5, that's why you are seeing 4, 2, 7, 9 all are printing the same number. Why? Because when one thread increments it as 855 and the other thread when it is reading it, all are working on same number, right? Mod 5 on a shared resource. That's why you see the same result. Here what we want to ensure is the number ends with 0 and 5. Let's run this once again, and if you see, so the result is not reliable, right? Sometimes you are having 0, sometimes we are having 5, so these are all correct, but here it is ending with 9, 7, 2. Now we will lock the resource and unlock it here. Here, if you see, there are multiple thread which is printing the number, and you can see all are coming with 5 and 0 or ending with 5 and 0. That means mod 5 is generating properly here. Right? So nowhere it is ending with 2 or 3. So that's the use of lock and unlock. So this is one technique, and the most useful technique is keeping this mod 5 generation as a member method inside the shared resource itself, and placing a synchronized keyword for the method. So if the method is gen mod 5 and if that performs 5 increments, and if you mark that method as synchronized, then the shared class or the shared object itself a thread safe method. So the user or the thread no need to worry about locking that resource, because the lock, I mean the class itself thread safe. All right, so now you got an idea of under what situation you will use lock and unlock. When shared resource, here in this case the shared resource is obj mod 5, which is of instance ex08 underscore mod 5. So the ex08 mod 5 is not a thread safe class. That's why the user here, this is the thread, right? And the thread is depending on the reentrant lock and locking the resource and unlocking the resource. So to make this mod 5 as a thread safe instance, you have to introduce a method here, and the method will be like public void gen mod 5. That's the method, and you have to mark that method as synchronized, and inside the method you have to increment this member 5 times, or you can use mod 5 equal to mod 5 plus 5, right? So that method becomes a synchronized method, and only one thread is allowed to enter the method, and that way the class itself becomes a thread safe class. And when threads are using that class and making call to gen mod 5 method, they no need to worry about logging the resource. All right, we are ending the Java threading series. Thank you for watching. Bye.